Today we're going to be discussing Apache Arrow. We're going to be discussing what it is, companies that use it, how it works, and some of its key features. My name is Joe Karlsson, and I'm a developer advocate at CloudQuery. And I am joined today by the amazing Yevgeny Pats, the CEO of CloudQuery, who, you may not know this, but CloudQuery uses Apache Arrow to solve some of its key features, which we'll be getting to at the end of the video today. Hi, Yevgeny. Thanks for being here today.
Hey, Joe. Excited for the chat.
Me too. All right, let's get into it.
So Apache Arrow is a cross-language data format for like in-memory analytics. A lot of buzzwords in that sentence, but I think we can like unpack it like in the next 10 minutes and explain why at all it's useful and who might be interested in that, because it is like the hot big thing in data engineering.
Yeah, well, tell me, what kind of problems does Apache Arrow solve? I think that helps give context for how you might use it in whatever problem you're trying to solve.
Yeah, so data formats, we do a lot of things with data. We have databases, we move data from place to place, and apparently each database has its own format. Each script that processes data has its own format, and that kind of introduces, a lot of wasted CPU time and coding time to transform things from one format to another, right?
Yeah.
And this kind of tries to standardize a lot of the tools and make it easy for developers or products like databases to use that instead of reinventing a data format in every single product. So that's one thing. And the other thing, it's also columnar data format. So we can also talk a little bit about what is a columnar, what is row data format.
Yeah, well, I'm familiar with row-based databases, but how does that column-based database different?
Yeah, so basically there are two types of databases, right? There is OLTP databases like Postgres, which is row-based. So what is row-based means that the data is stored in memory and in disk, like row-based. So you have like
an Excel spreadsheet.
Excel spreadsheets, exactly. Like in memory, first you have one row, and then you have the second row, and so on. So that's one thing, and this is very useful if you want to update a certain row, and you want to have transactions and strong consistency. But apparently, when data really grows and you move to analytics, there is a neat trick that engineers found out, that if you store the data in a different way, like in columnar, for example, you first store all the columns of the name. If you have a table, name and age, people, right? You store name, age, and address. So if you store all the names first, then all the ages, and then all their addresses, apparently it's much more efficient to query that.
Yeah, because they're closer in memory. They're you don't have to go all around to get all the data for that one column. It's all together.
Yeah, exactly. It kind of ties back to just how memory works, how a hard drive works, and then also it's easier to compress. So it's very easy to compress data from the same type, rather data if you have data from different types stored right after each other. So kind of compression and going through data is very quick, and that's what people find out, and this is why we have things like BigQuery, Snowflake, ClickHouse, which the data is stored in that way.
And how does Apache Arrow use a column-based database? How does that make it faster than other solutions?
Yeah, so Apache Arrow is a columnar in-memory format, right? So it's usually it's in memory. You can also store it on disk in the same format, but for example, if you want to build a new database today, you need to decide on in-memory format that you pull data out from the disk to a memory, so you can do some queries on that or do some processing. Then you can use something like Arrow. So I think, for example, a database like InfluxDB, and kind of analytical database, they use that instead of building their own. BigQuery and ClickHouse have their own Arrow-like in-memory formats, but they have actually they have connectors already for Arrow, which means they support like native, a lot of them already support native Arrow. So you can speak Arrow to that database without like the need to transform your data to yet another data format if you already have it in Arrow. Pandas is a Python library. Like it's also a data format, but it's strictly in Python.
Yep.
So if you want to do, well, maybe the history of like Arrow, a bit of history of Arrow also will be helpful, right? So,
yeah, I love that.
So Python. So before Arrow, or actually the author of Arrow is Wes McKinsey, I think his last name. Sorry if I butcher his like last name, but
we'll put it on the screen here.
Yeah,
yeah.
He was also the author of Pandas, which is the most popular Python tool for like analysis and manipulation, and it's two things. Pandas is two things. One, it's a Python library that you can use to do exploration for data, but also it's a data format as well. So it stores the data in some way, and then it also enables you. Data frames, exactly, and then it also gives you the Python library to work on top of that data. So the founder said, okay, like this is Python only. This is like yet another data format. Like we can do better. It shouldn't be only in Python. It can be useful in other places as well. So if we build a data format that is cross-language, then this data format, we will be able to build kind of bindings and libraries in any language for the same data format. Databases would be able to reuse it. The people writing Python would be able to write kind of exploration code and transformation code directly on that data format instead of if everything is in their own, instead of like transforming it to pandas and working here, or if you work in Java, you use like whatever, like some pandas for Java, which is yet another data format. So like it's a lot of CPU moving data from one data format to another. So really trying to kind of standardize it and work in any language and for like many different use cases.
You know what it reminds me of? Are you familiar with the Babelfish from Hitchhiker's Guide to the Galaxy? It's like the thing they put in everyone's ear and it translates everything in real time. But this feels like a Babelfish for data.
Yeah, exactly. I think it's a great. I like that. Yeah, it's a great analogy.
What you're saying is like Apache Arrow allows you to like, it was created to like translate different data types around, and it does it without having to like save things in memory, like persisting, and it can just translate them. Because every database has like slightly different ways of doing things, the different data types, and it needs to be able to talk to those different databases and move data around quickly. And Arrow does that.
Yeah, exactly.
Let's talk about CloudQuery and how it uses Apache Arrow. I think it'll help give like some specificity to how companies are really using it. So why did you choose to use Apache Arrow at CloudQuery?
Yeah, so we didn't start like in our first iteration. We just kind of started building the thing. But CloudQuery is an ELT framework, which means you can write a plugin to get data from like let's say an API or some data source.
Yeah.
And what this framework gives you, it gives you a bunch of things, but in the grand scheme of things, transforms data to like an intermediate data format. Like as a developer, you're not like really aware of that. And then you can write the plugin once, and then you can sync it to any like destination. You can sync it to Postgres, you can sync it to BigQuery, to Snowflake, without writing destination specific code. So that's like the big thing. Of course, like it gives more things, but in the grand scheme of things, you write a connector once to a source, and then you can sync that to any destination, and that's quite useful. To do that, we need an intermediate data format. We chose Arrow because it is already there, and it gave us quite a few things that we don't need to develop. Actually, initially we started with our own data format. It was only for Go. That was one thing. So the next thing, people asked us, hey, can you also provide an SDK for Python? And then, all right, now we have our own data format that we invented, and we have to re-implement everything in Python. And then like JavaScript and Java, so it would be a lot of work. So yeah, we were on the hunt for data formats, and we found Arrow, which means when we were implementing our SDK for Python or for JavaScript, a lot of the things like for the data format specifically were already implemented, because there is a Python library that knows how to encode and like kind of decode Arrow, send it over the wire, deal with it. So yeah, that was kind of just for free, almost for free. We did contribute a lot to the Arrow Go library because it was still new and things were missing. But yeah, it was great kind of to put effort in the one data format.
No, I totally get that. So it sounds like you started building your own like data transfer, like ETL tool in Go, and then you tried to like expand it out, and you realized you'd have to reinvent the wheel every single time you wanted to port over to new language. And if by using an Arrow, you were able to just cut out the middleman, use a tool that can translate to any programming language, has a robust plugin library with those programming languages, and allowed you to convert between these data formats kind of out of the box.
Yeah, exactly. So Arrow has like Python, Go, JavaScript, Rust, C++. So if you're writing code that deals with that data, you already have those libraries that know to like native libraries that you can work with that data out of the box.
And I'm curious, since you like had started building your tool out in Go and then you ported to Arrow, did you see any performance gains from converting over to Arrow from your native tools?
I think we saw that as well because there were things that in our data format that we kind of hacked together like we didn't think about. And yeah, there is a lot of thinking about performance in Arrow, like in how they kind of define how they store data, how they move data, especially columnar data. Yeah, I think it's pretty like it's very thoughtful, and like it's a mature project. It started like sorry if I'm using them the wrong starting date, but maybe 2017 or like whatever, 18, right? Like a while back. It's they thought about a lot of those problems.
Totally, and they're getting contributions from lots of different companies who are using it. I generally trust a project that's on Apache Arrow, especially a mature project that's been kind of community managed like that. Okay, cool. Well, awesome. Thank you so much for walking us through that. That's amazing. So we talked about overview of what Apache Arrow is, the types of problems it solves. We talked about some of the key features of Apache Arrow, it being a column-based database and allowing to do zero write copies. All right, I think that'll do it for today's video. So we talked about Apache Arrow, its history, and some of its use cases for how it's getting used by different companies today, including CloudQuery. But if you're interested in trying Cloud or you're in need of an ETL tool, you should for sure go to cloudquery.io and give it a shot. It's totally free to get signed up. And if you want to just hang out with our engineers or our developer community, you should check out our Discord. You can also find that on our website. Otherwise, like, subscribe, and comment if you like this video and want to see more like it. Thanks, Yevgeny, for joining me today.
Thanks, Joe.
All right. Bye, everyone.